Hello everybody, we're getting ready to do 5.1 for SAT Math Level 1, which is about rational exponents. So if you need online tutoring, test worksheets, more PowerPoints and video, solution PowerPoints, contact me here at this email, and I'll get right back to you. Lesson 5.1 Rational Exponents. We have 24 points here of note-taking. I can provide note-taking guides. And we got a 52-point skill sheet at the end of this PowerPoint, which is not included in this video. So if you need that, contact me. 24 points here. You can take notes off this video, though. But you need a worksheet, so contact me. Passport to Advanced Math. Chapter 5, Passport to Advanced Math represents the third of the four major mathematics content groups tested redesigned SAT lessons in this chapter. This is what's in this chapter here. Overview of the chapter. In order to give meaning to expressions such as 4 to the negative 1, 4 to the 0, 4 to 1/2, the rules of exponents can be extended to include exponents that are rational numbers. Equations may contain variables with rational exponents or variables underneath the radicals. So we need to know what's going on with that. Zero, negative, and fractional exponents. Zero exponent rule, negative exponent rule, and fractional exponent rule. X to the 0 would equal 1. Example, 2 to the x to the 0 power would equal 1. Negative exponent rule, x to the negative a. So 1 over x to the negative a equals x to the a. It reciprocates this to this, and it reciprocates this to that. Example, here's an example here. These reciprocate down, this goes up. This stays where it is. And then 1 over x to the n, this would be the way it would look, to the nth root of x. X to the a to the nth would be x to the a power to the nth root, and this would be the way that you would further simplify that. An example here would be negative 27 to the 2/3 power would be the cube root of negative 27 squared, which would be negative 3 squared, 9. Here are other examples here of exponents. So 3x to the negative 2, this would reciprocate here. The x to the negative 2 power would reciprocate. And then here you have power of power, here going on here and up here. And then you could put it in this form with using negative exponents up here. This cancels up here, this becomes x to the 3rd, and then this cancels with that, becomes y to the 4th, or x cubed y to the negative 4. And then this here, we have x to the 1/3 over x to the 1/2, which equals x to the negative 1/6, because we use our quotient power of exponents, or we could write it this way here. We could keep it down in the denominator, and 8 to the 4/3 would become this here, the cube root of 8 to the 4th power. And then up here, we do our manipulations here for negative exponents here, and then we simplify and we end up with b to the 4th over 2c to the 5th. These flip, and then we can further factor out by that. And then x squared over x to the 1/3, this would be the actual form of this here, and without the fraction bar. And then we use power of power properties here. No, we would use the product of power properties here. So it'd be x to the 5/3, and then that would be it in radical form here, be the cube root of x to the 5th. So that would be the way that you manipulate exponents. So we have an example here, x greater than 1. Then we have this expression here, what is the value of n? Rewrite using the exponent rules. So they're using the quotient law of exponents. Simplify the exponent here. So we have x to the 3/2 minus 4/2 equals x to the n. X to the negative 1/2 equals x to the n. N would equal negative 1/2 by using the exponent rule for solving equations. So our choices would be x to the negative. Radical equations. If an equation contains square root of a variable term, eliminate radical by raising both sides to the same power. So we have this radical here. Raise both sides of the equation to the second power. So we square this and square it. And then simplify it. We have this here, and then we just solve for x. And then math reference fact here to solve an equation of the form like this. Raise both sides of the equation to the nth power like this here. So x is equal to c to the equations with fractional exponents. Since the reciprocal of 3 over 2 is 2 over 3, raising both sides of the equation, x to the 3/2 would equal 8 to the 2/3 power creates an equivalent equation in which the power of x would be 1. So in this situation here, x to the 3/2 times 2/3. So to bring this to solve this, we would go down into here, and then x is equal to the 2 squared, which would equal 4 in this situation here. X to the 3/2 equals 8. So if we reciprocated here, if we multiplied this by 2/3 power and this by 2/3 power, we would get this situation here. X would equal the cube root of 8 squared, which would be exponential equations. If an equation contains a variable and exponent, rewrite each side as the power of the same. So simplify the exponents. So we have this here. We have x plus 1, 2 cubed to the x minus 2, 2 squared to x plus 1. Set the exponents equal now. So now we can drop this down, and then we keep this here and keep this here. These go away, and then we solve for x.